Okay. So today we are going to check on that. So the main goal is just listen, watch this. There's a lake. Can you see the lake here? Yes or no? Okay. Now in order to figure out what is the width of the lake, like how far is this lake from this to this, how do we do that? So a surveyor, a guy who is right here, so what he does is he walks all the way from here to here at one place. Can you see that? And he finds the distance. He maybe whatever miles, maybe 1 mile, whatever, 2 miles, and also from here. So he goes from here, marks one point from both distance, and he knows that distance, and he can know the angle also by just knowing that angle at the two sides. You see the two sides? So he know how far is this at the end point of the lake from C, and how far is this point A from C. Once you know those two things, and if you know the angle between the two, and we can figure out what is the width of the lake. So the question is, the formulas are just so easy. Is if this is B, this is A, and you call this as C, this is a lowercase c. Can you see that? So you kind of given, I'll tick mark, this is given, and this is question mark, right? So all you do is, hey, which formula works? That's all you do. You can see the formula here, c squared. Do you see the c squared here? So c squared, and then is, and you kind of think of like a circle like this, a round, and you put A, B, and C. Can you see the clockwise? So the clockwise, if you want to know C formula, let's see, you want to know what is C formula, then you start with C, then goes to A, then goes to B. That's what it is. If you start C, then A, B. If you start B, then C, A. If you start A, then B, C. And that's how these formulas are easy to remember. Everybody does that. So if it is C squared, after C is what? What is after C? A. So it is A squared. Can you see that? Then comes B squared. After A is B. But then you have to remember this minus sign. And then this, whatever AB is repeats here. Do you see that AB repeats? And then cosine of the angle C. Can you see this? This is that C. So if it is B square, after B comes what? After C is A. And that same CA repeats. Can you see that? So that's kind of easy to remember. And then you put the cosine of the angle. The question arises is, how did this formula come from? So this I want to show before we solve those problems. Straight away we are going to work on those. So this is the case, and this same thing, the top one, this is 1, this is 2, let's see, and this is 3, and this one is connects to the first one here. Let's call this as A. Oh, no, I won't call it A because I'm using ABC. Call it as this 1, 2. They are kind of straight away. Sometimes they give you all the 3 sides. So sometimes you may know all the 3 sides. How do you find the angle? Got it? So just the opposite. So let's check why. So I'm going to put this off. Okay. How many of you remember Pythagorean formula? Okay, let's do that. So I hope you have written down. What I'm going to do is I'll try to use 2 triangles here. The first one is so this is A, H, C, and this is B. Okay. The other one is again A, and this is C, this is B. Okay, so what I did, I tried to split those. I split that triangle into 2 triangles. You see that? 2 triangles. Okay. So those who came late, it's just that I'm trying to prove this formula, why this, so the question is why this one, the first one. So you have a triangle, you drop a altitude, you can call this as D also, let's call it as D. Okay. Now H is the height, and then let's call the BD, we need to know, in order to figure that, prove that it's better right now, we don't know what is this much, call this as X. Can you write this as X, something like a variable, we don't know. And because BD, BC all the way is A, how much will be this one? Somebody can tell? This whole thing is lowercase a, right? And this one is X, so how much will be this one? If I say this is 15, right? And this is 7, how much will be that? 8, how did you get it?
Because you subtract x from a.
X from A or A from X?
Or
Yeah, X from A, yeah, you're right. So that is X. You take away, A is the bigger one, right? So that's the A. So A minus X. Can you write down this? So now I'm going to put that right here, put the X here, and this is A minus X. And I'm going to use a Pythagorean formula for both. So let's use okay, Nathali. So what did I do? I split the triangle into two parts. Okay. Actually, you're not supposed to draw this extra. I'm just doing extra just to get too much of stuff on one place, confusing. So separate them. Okay. Now I'm going to use Pythagorean formula for the first one. Somebody help me. How do I write Pythagorean formula for the first one? For this one. Quick. What's the leg? Which are the legs here? X and H. So what do you do with them? What do you do with those? Did you really forget the Pythagorean formula? This is the hypotenuse, right? Those are the legs. This is one of the legs. This is the other leg, right? So what do you do with that?
Square.
Yeah, square them. So you square what? What? X squared. Then what else? H, which you don't know, right? It equal to? Yeah, C squared. Then put this in the box. That's the first part. Yeah. What is it?
Sorry,
Akima? This is for what? I'm marking absent. Can you write everything? I'll just sign it. You don't put dates which are yeah, just sign it. Put the date, everything, and I'll sign it. Okay, I got it. Let's do quickly. Can you tell me Pythagorean this side? Quick. What are the legs here?
H squared.
Okay, H squared. Then what else?
A minus x squared.
Okay. What's the hypotenuse there?
B squared.
So far so good? Okay, what we do next is we'll try to expand this. Now see, we can't have A minus X. Do you remember the trick that I showed? If I have, let's see if it is P plus Q, the whole square, how many of you remember? You can directly say square the P, square the Q, and you multiply the two and double it. Do you remember this? Square the first, square the last, in between you multiply and double it. Just say yes. Can I have it? Okay, so how do I do it? right here expand. So h square stays the same. Natalie, can you tell me how to expand this? So remember, if this is minus, this will be minus, right? That's how it works. So a square then
minus 2ax
ax, very good. And then
plus x squared.
very good. Got it? So far so good? So sometimes proofs are, nobody likes proof, right? Nobody wants to know all this. You just apply, they say, hey, okay, Jocelyn, after this, do you see something here? Do you see this part over there? On the left side, do you see that?
No. But they're together? Like
Not
this?
together, but do you see x squared and also h squared over here?
No. Mhm.
You see this? Do you see? So what I'll do, I'll try to put them together, these two. Can you see that? So put them, club them together, h squared plus x squared. And this a squared minus 2a. I'm gonna write this as blue color. Let me put a color for that. And this equals, so we are almost there, okay? Just 2 minutes, we are done. Now, what do I replace this by?
Minus
C square? See, somehow we want to get away with the h and x. So in this case, we just put c square, so we replace it by c square plus a square and 2a, and I want to replace x also. So how do I replace x? How do I get cosine here? This is lowercase c, okay? How do I get cosine from this? Look at this. Because the formula has cosine b. Do you see the cosine b in the formula? So can I write cosine b? What is the definition of cosine b? Hugo, what is the definition of cosine? Say it again.
Opposite over hypotenuse.
Can we use that? Is it opposite of a hypotenuse? Or is it
Adjacent.
Yeah, so what's the adjacent here? So if this is the angle, so my reference angle is this one, so that's the angle, right? So which is is it the h is the opposite or x is the opposite? Yeah, that's the adjacent, right? And that's the hypotenuse. So let's do quickly. So this is x is the opposite over, and the hypotenuse. Is that okay? Nobody's saying yes. Now remember, we need to replace this x, right? The blue color x. So in order to replace that, we want to isolate, we want to keep x by itself. So we want to get away with the lowercase c at the bottom. So multiply c this side, multiply c this side, correct? So that way, so this c crosses out, that's one. And x equals, so look at this x equals, so x equals c cosine b. I'll put this in the box, that's the important part. Lot of work, right? Too many variables. Where do I plug this in? What do I replace in the, see I left a space there, do you see the place I left here? So what do I replace here? So x should be replaced by,
C times cosine.
yeah, c times cosine b. So this is c, I'm putting, let me put a color. So c cosine b. Is that okay? Now angle is always put in the parenthesis, so I put this in the parenthesis. Equals b squared. And we already proved, and we already done this. See how you get it? So we want to know what is b squared. So I'll rearrange. So that b squared, I'll put it in the beginning, equals, after b c, so c squared, then there is a plus a squared, Now, somehow I will rearrange instead of AC, let's write it as CA, okay? And then times cosine of B. Ha ha ha, and you're done. Got it? So this is, it's always better to know where the heck this formula come from. And I try to show you the first one. Is that okay? Did you get it? So if you get confused, as I say, I'm posting the video clip. I'll post it in the Google Classroom. You can watch it in case you are confused. So the main thing is you can remember this, right? So b squared. Another thing, one more thing I want to show you. Likewise, you could do the other two also by taking the angle. Remember, I took the angle B, or you could have taken C here and change the order. Everything changes. Now the next is why this part. So let's check why is this one. And the trick is like this. Can you tell me, Messiah, what is 2 plus 10 minus 5? Two plus 10 minus 5, how much? 7? 7, right? Agree? Now watch this. Can I just do like this way? You know, swapping, it's like you're adding plus 5 here and go take it on the other side. So that is 5. And this 2 plus 10 stays there. And this plus 10, what I do? Subtract 7. Do you agree? Do you get the same thing? What is 2 plus 10? 12 minus 7? Correct? So it works, right? So we will apply the same thing. Do you see the minus sign here? And the long thing, we can take it on the other side. And this b square, you take it on the, make sense? Just apply using this trick. So as I say shortcut, I'm doing shortcut here. So therefore, this step, so I'm going to take this minus will be plus 2ca cosine b. Take it on the left side. These two things stay the same. And that b square goes the other side as b square. Do you see that? Only thing here, there are too many variables. But that's the trick that I showed you. So this expression which is negative, can you see this is negative? So it goes as positive on the left side. Do you see that? The orange color, this is that orange color. And the other blue color, so this blue color, let's see, this one, that goes here. Agree? And why did we do this? Is because the next is you want to get this part. The goal is, hey, what is cosine b? So let's divide both sides by this 2ca this side, 2ca this side. Bless you. Until lunchtime. Oh, that's not nice. Until till you get married, have children and grandchildren, and big house, and then buy a jet to go to space, right? Okay. So this 2ca crosses out. Can you see that? You go? So cosine of b, so that's why if this is c squared plus a squared minus b squared over 2ca, done. So we have proved this. So when do we use this formula? The question arises, how do we know when to use? So you can clearly see this formula on the right side. So A, B, C, all three sides should be known. So basically this formula helps if it is all S, if you know all the three sides, you can apply cosine rule to find the angle. Okay. But this formula works two angles, two sides and included angle is given. So if you know two sides, like remember that we wanted to figure out the width of the lake, and you wanted to know, go on either side, you go to a spot, main place, and see the distances and see how much is the angle, and then we figure that out. So the point I'm making is, how many of you understood this proof? Thumbs up. All of you? Dang, that's easy, right? The question is why teachers don't teach this? Can somebody tell me? I mean, everybody gives the formula. Oh, okay, this is the formula. Like you have two sides and an in-between angle, you use that. And they say, okay, this one, if all three sides are given, use that. And you do 100 problems. Teacher gives a big worksheet, right? You start working, sit down. But my goal was to really make you realize that, hey, it just doesn't exist. There's a reason, right? There's a nice proof that it shows. Last time we showed, remember the last time we showed is A over sine A, the sine rule, and B over sine B. Why does this exist? And this was only for AAS when two angles are given. See this part? But the cosine rule, SAS doesn't work for sine rule, and that's why we have to have this part, this kind of situation. So it's good to know this. Okay, now we'll go directly. You can open your laptops and see how far we are, and then we'll do sine rule in case if you got confused with some of this problem, and then we go to the cosine rule. Okay, because fifth problem I think is cosine rule, where you need to figure out, hey, what's the distance? Is that okay? Okay, so let's go.